Rajesh. Today I am going to discuss about digital control systems. In that, I am going to explain the first unit, Introduction to Signal Processing. So before moving to that, first let us see what do we mean by a signal. A signal is nothing but anything that carries some information is said to be signal. Information means it may be of either voltage or current or temperature or anything. So anything that carries some information is nothing but signal. So signals are generally divided into three types. One is continuous time signal, and second one is discrete time signal, and third one is digital signal. So what do you mean by continuous time signal? You can see it in the waveform. See here. So this is said to be a continuous time signal. So a signal that is varying continuously with respect to time is said to be continuous time signal. Now if you take only some of the instants of this waveform, I am taking this instant, I am taking this instant amplitude, and I am taking this instant amplitude at a regular intervals of time. So now this is said to be a discrete time signal which is varying with respect to k. Now x of t is a continuous time signal and x of k is a discrete time signal. So what is the difference between these two signals? So this is the signal which is varying continuously with respect to time t, and a discrete time signal means it is having amplitudes only at regular intervals of time, like k, 2k, 3k, up so on. If you put k equals to 1, it is at means t, 2t, 3t, and next 4t at this instant, and next at this instant 5t, where t is called sampling period. What do you mean by sampling? Sampling is a process which will convert continuous time signal into discrete time signal. Means we are taking samples. Sample means amplitude at this instant t, and again after one more time period we are taking one more sample at this instant. At this instant means at 2t, this is the amplitude, and at one more time period of t we are taking this sample which is equivalent to this. Now continuous time signal is being converted into discrete time signal by applying the process of sampling. Now what do you mean by this third signal, digital signal? Digital signal is nothing but a discrete time signal which is being quantized. Quantized means we will assign the digital code for each and every amplitude of this discrete time signal. Means if this amplitude is something 5, then we will assign 101 to this amplitude. Means if discrete time signal is being quantized, then that signal is said to be a digital signal. So that is the main classification of signals: continuous time signals, discrete time signals, and digital signals. Next, let us see the basic block diagram of digital control systems. So digital control systems are nothing but normal control systems which are being operated in the mode of digital mode. Let us see the basic block diagram of digital control systems. So this is digital computer, and this is digital coded input, and here this is digital computer, and here it is controlled process. We will take the feedback, and here it is analog to digital converter, and again it is feeding back. So this is digital computer where the algorithms are being processed, and here we are giving the digital coded input, and here this is called digital to analog converter. So we are giving the digital coded input here. Here it is of digital computer where the algorithms and programmings are being coded and which are being used to control the process. And here it is digital to analog converter which will convert the digital signal into analog signal. We are having different types of D2A converters like weighted resistor method and so on. And here this is the process which is to be controlled. And here the output again taking back, and it is processed through A to D converter. So A to D converter means analog to digital conversion, which will convert the analog signal into digital signal. And again this is feeding back. So we are having different types of A to D converters like successive approximation ADC, counter type ADC likewise, and this is the output. So this is the basic block diagram of digital control systems. Of course, sometimes we can take the analog signal as input. In that case, the block diagram will vary slightly. Here, this is the analog signal. So here it will be having some error is being converted. Here you will be having A to D converter followed by D to A converter followed by output. If you take the analog signal as input. So this is the block diagram for digital control system and the basic components. And next, let us see the advantages of digital control systems. What are the advantages of digital control systems? So, digital control systems are less susceptible to aging of all components, less susceptible to aging of all components in the diagram, in the structure. And second, it is less sensitive to noise and disturbance outside, noise and disturbance coming from outside, and it is also less sensitive to parameter variations in the system, and it is light in weight, compact and light in weight. So these are all the advantages of using digital control systems in the operation. And next one is the cost was also less when compared to equivalent systems. So less susceptible to aging of components. Aging is being reduced when compared to other components. Less sensitive to noise and disturbance coming from outside, and less sensitive to parameter variations in the system, and light in weight, and cost is also less. And because of usage of computer, microprocessors, all these things in the system, it is also flexible for programming and coding. Flexible for programming and coding for using different types of algorithms. These are all the main features and advantages of digital control systems. Now let us see some examples of digital control systems where the digital control systems are being used. And one is rolling mill regulating system. Rolling mill regulating system. Let us see the block diagram, how it is being used in the rolling mill regulating system. This is unwind reel. This is unwind reel. This is the digital computer where digital control system is being used. The inputs for this digital control system is inputs, drive speed, thickness, and tension. Thickness in the reel, tension in the reel, and the drive speed. These are the input commands to this digital computer. And here, from here, we are sensing the thickness, and it is being fed to digital computer. And from here, we are sensing the tension using some transducers, and it is giving signal to digital computer. Of course, the output command should also be given. Yeah, so this is the output signal which is being given to thickness controller, and here also okay. Yeah. So from here we are taking the tension as signal, And again, this digital computer will give the feedback signal to this tension controller to control the tension in the reel. And first we will take the thickness as a signal, and here the controlling process will be done, and for the signal for controlling the thickness will be given here. So we are sensing the thickness and we are controlling the thickness. We are sensing the tension and we are controlling the tension. By using this digital computer, inputs are drive speed, thickness and tension. And here if you want to see, then you can use CRT display. And this is, finally this is rewind reel. So in this way we can use the digital computer systems in rolling mill regulating systems. Of course, there are many examples for digital control systems. One is you can use it in interest payment applications, and you can use it in stepper motor control. You can use it in stepper motor control, and you can use it in turbine generator control. Of course, you can use it on single axis autopilot control systems. In this way, we can use the digital control systems in number of applications. So these are all the examples of digital control systems.